Just imagine for a moment a world where everything around you is made up of individual atoms with no chemical bonds holding them together. Can you even begin to imagine what the air you breathe or the ground you walk on would look like in such a world? It's a difficult concept to grasp, but fortunately, that is not the world we inhabit. Our reality is composed of various types of atoms that unite to form molecules, and these molecules then join forces to create compounds. However, have you ever pondered the question of why and how these atoms and molecules bond together? This is a question that has confounded scientists for centuries and remains one of the most profound mysteries of our universe. Are you ready to uncover the secrets of chemical bonding? In this Class 11 video, we will explore the captivating world of chemical bonds and delve into the fundamental process by which atoms, molecules, or ions come together to form a stable chemical compound. There are several theories that explain the nature of chemical bonds, including the Coulson-Lewis approach, valence shell electron pair repulsion theory, the valence bond theory, and the molecular orbital theory. In this video, we will delve deeper into what is chemical bonding and why chemical bonding occurs to form compounds. Specifically, we will also focus on the Coulson-Lewis approach, also known as the Lewis theory of chemical bonding, which was one of the earliest and most influential theories. We will cover essential concepts under the Coulson-Lewis approach, such as the octet rule, Lewis symbols, and more. Get ready to uncover the secrets of chemical bonding in this exciting video. So, what exactly is chemical bonding? Chemical bonding is the fundamental process by which atoms, molecules, or ions come together to form a stable chemical compound. Atoms, as you know, are composed of three types of particles: positively charged protons, neutral neutrons, and negatively charged electrons that orbit around the nucleus. The electrons in the outermost shell of an atom, called valence electrons, are primarily responsible for the formation of chemical bonds. In order to achieve stability, atoms seek to either gain, lose, or share electrons. When atoms come close to each other, the electrons in their valence shells interact with each other, leading to the formation of a chemical bond. Overall, chemical bonding plays a critical role in the formation of matter in the universe, as it enables the creation of countless chemical compounds with a vast range of properties and applications. Now, let's explore the question, why chemical bonding occurs to form compounds? Chemical bonding occurs to form compounds due to two main reasons: the tendency to acquire minimum energy and the tendency to acquire noble gas configuration. Let us discuss them one by one. First reason of chemical bond formation is tendency to acquire minimum energy. As we know, the behavior of charged particles plays an important role in the formation of chemical bonds. Unlike charges, such as a positive and negative charge, are attracted to each other, whereas like charges, such as to positive or to negative charges, repel each other. A similar phenomenon occurs when two atoms approach each other to form a bond. When two atoms come close to each other, the positively charged nucleus of one atom attracts the negatively charged electrons of the other atom. However, the negatively charged electrons of one atom repel the negatively charged electrons of the other atom. This results in a combination of attraction and repulsion forces acting between the two atoms. According to the principles of quantum theory, these opposing forces create a balance at a certain minimum distance, which is known as the bond formation condition or equilibrium state. The atoms of elements become stable by forming bonds, which lowers their energy. If the net result of the attraction and repulsion forces is attraction, then the total energy of the system decreases and a chemical bond forms. However, if the net result is repulsion, then no chemical bonding is possible. So, chemical bonding is a phenomenon that occurs in order for atoms to form compounds and achieve a lower and stabilized energy state. The second reason of chemical bond formation is tendency to acquire noble gas configuration. In addition to the tendency to achieve a minimum energy state, chemical bonding is also driven by the desire to attain a noble gas configuration. Elements in the inert gas group, such as helium, neon, and argon, have stable electronic configurations and are not chemically reactive. Atoms of other elements combine with each other to achieve the same stable electronic configuration as the inert gases. The most stable configuration is to have either 2 electrons, in the case of the first energy shell, or 8 electrons in their outermost energy level. This configuration is called the octet rule, and it is the state of maximum stability and minimum energy. Only the electrons in the outermost energy shell, which are known as valence electrons, participate in the bond formation. These include the ns, np, and n-1, d orbitals. Therefore, atoms combine to attain a stable electronic configuration and lower their energy, which leads to the formation of chemical compounds. This desire to achieve noble gas configuration is a fundamental driving force behind many chemical reactions and the basis for the octet rule, which is a topic we will be discussing in detail later in the video. Up until this point, we have covered the definition of chemical bonding and the reasons behind its occurrence in compound formation. Moving forward, we will delve into the initial theory of chemical bonding, also known as the Lewis theory or Kossel-Lewis approach. What exactly is the Lewis theory of chemical bonding or Kossel-Lewis approach? The Kossel-Lewis approach, also known as the Lewis theory of chemical bonding, is a fundamental and influential theory of chemical bonding proposed by American chemist Gilbert N. Lewis in 1916 and later refined by German physicist Walter Kossel. The theory explains how elements combine to form compounds and molecules and what makes chemical bonds so strong. According to Lewis theory, atoms consist of a positively charged kernel and an outer shell that holds the valence electrons. Atoms are considered most stable when their outer shell is filled with 8 electrons, which is called the octet configuration. Achieving this stable configuration is crucial for atoms as it symbolizes stability. Atoms can achieve this stable configuration by forming chemical bonds with other atoms, following the octet rule. The octet rule, proposed by the Kossel-Lewis approach, is a fundamental principle in chemistry that states that atoms tend to gain, lose, or share electrons to achieve a stable configuration of 8 valence electrons in their outermost shell. This principle applies to most elements in the periodic table, except for hydrogen and helium, which only require 2 electrons to achieve stability. The Lewis theory of chemical bonding visualizes the sharing and transfer of electrons to achieve the stable configuration of 8 electrons in the outer shell. During chemical bonding, atoms gain, lose, or share electrons and become stable. In an ionic bond, atoms transfer electrons and become ions. The octet rule can explain the formation of sodium chloride through electron transfer, resulting in an ionic bond. Sodium has 1 electron in its valence shell. It will lose the electron and become sodium ion. Chlorine has 7 electrons in its valence shell. It will accept the electron from sodium, will transform itself to chloride ion, and take the stable electron configuration. Whereas, in covalent bonding, atoms share electrons. Covalent bonding in carbon dioxide can also be explained by the octet rule, which involves the sharing of electrons. Specifically, carbon has 4 valence electrons, while oxygen has 6. Based on the electronegativity difference between carbon and oxygen, we can predict that the chemical bonding in carbon dioxide is covalent. As a result, carbon and oxygen will share 2 valence electrons and form 2 double bonds. Ultimately, both carbon and oxygen will have 8 outermost electrons in carbon dioxide. After discussing the octet rule of the Kossel-Lewis approach in detail, let's now summarize this approach. The Kossel-Lewis approach, also known as the Lewis theory of chemical bonding or electronic theory of chemical bonding, proposes that only valence electrons participate in the formation of chemical bonds between atoms. In order to achieve a stable octet configuration, atoms will either share or transfer electrons. I hope you have got a solid understanding of the Kosselevi's approach. Let's dive straight into the final topic of this video. What are Lewis symbols and how to draw them? Lewis symbols are a type of notation used to represent the valence electrons of an atom. They are a simple and effective way of depicting the outermost electrons of an atom, which are crucial in chemical bonding. In Lewis symbols, the chemical symbol of the atom is written and the valence electrons are represented by dots around the symbol. The number of dots in the Lewis symbol corresponds to the number of valence electrons of the atom. By using Lewis symbols, chemists can easily represent and analyze the electron configurations of atoms and molecules. For example, the Lewis symbol of carbon depicts a C surrounded by 4 valence electrons because carbon has an electronic configuration of 1s2, 2s2, 2p2. Electrons that are not in the valence level are not shown in the Lewis symbol. The reason for this is that the chemical reactivity of an atom of the element is solely determined by the number of its valence electrons and not its inner electrons. Have a look at some examples of Lewis symbols of different atoms. To draw the Lewis dot symbol of an element, we must first know how many valence electrons it has. Remember, this is easily determined based on the group number of the element since valence electrons are the ones in the outermost energy shell of the element. For example, oxygen is in group 6, and therefore, it has 6 valence electrons. And just like this, we can draw the Lewis symbols of all the main group elements. Simply add dots one by one to represent the valence electrons. For instance, magnesium is in group 2A, so it has 2 valence electrons and is represented by 2 dots, while C is in group 4A and has 4 valence electrons, represented by 4 dots. So, this concludes our discussion on Lewis symbols. I hope you found the information about chemical bonding important and enjoyable in this video. Looking forward to seeing you in the next one. And now, you should start studying this chapter with the EduRev app as you get video lectures, notes, variety of questions, and MCQ tests for all the chapters of each subject. It's like having the entire school in your pocket.